Okay, so the next video we got here is power and efficiency. So power is related to work, and what it is essentially, well, it's actually proportional to work. In other words, if you have twice the amount of work, you have twice the amount of power, but it's important that it's in a certain amount of time. So power is equal to the rate of doing work. How fast you're doing your work. And so the formula for it is P equals work over time, or it could be P equals energy over time. So remember, work is the change in energy. And if you use the E, you must also be a change in energy as well. Now, if we go to number 2 there, if a Mini and Ferrari have the same mass, remember this, that's in kgs. Imagine they're both 1,000 kgs and can reach the same speed, okay? If they have the same V, and doesn't really matter what it is in, meters per second or kilometers per hour, then, and we say it's 100 kilometers per hour, then both of them have the same kinetic energy. Okay, but why do we say the Ferrari is more powerful? Well, if we look at this formula, power equals work over time, or energy over time. If they have the same kinetic energy and have gone from stationary, here's my Ferrari, they've gone from stationary to a certain speed, then they increase their kinetic energy from 0 to something, let's say 10,000. Okay. If they increase that kinetic energy, that is the amount of work that's been done. But because they both have the same amount of kinetic energy, they've both done the same amount of work or energy. So this value here, the energy or the work, is the same for both. So what's different though? A Ferrari would go much faster, okay? So a Ferrari would have a smaller time than the Mini to get to 100 kilometers an hour. So the time for that change would be smaller. And that means if this bottom line of the fraction is smaller, then the power must be larger. So time for the Ferrari is smaller, so power will be larger. Okay, 3. If a car accelerates from rest to 100 kilometers an hour by gaining 200,000 joules of kinetic energy in 20 seconds, what is the car's power? So power equals, what do you want to do this time? Energy over time. And so that's going to be equal to 200,000 divided by time. Now, 100 kilometers an hour is not time, but 20 seconds is a time. Okay, it's going to have 1, and you're going to knock off a 0. Have I counted right there? Hopefully I've counted right. Okay, so it's 10,000 watts. 4. A light bulb transforms 400 joules of electrical energy into heat and light in 4 seconds. What is the power of the light bulb? So power equals energy over time. So that equals 400 joules divided by the time, which is 4, and that gives you 100 watts. Next one, number 5. If only 140 joules of energy was used for light and the rest was wasted as heat, how efficient is a light bulb? What percentage of the energy was useful? So we've got 200 joules total. 140 was useful 60 joules was wasted. Okay, so which one of those is the useful one? Was the 140? How much of the percentage of the total? To find a percentage, we're going to do 140 divided by 200. How much times 140 goes into 200? We multiply by 100 to get a percentage. So 140 over 200, well, that's about 70%, sorry, 70, and you times that by 100 and you get 70, so 70%.